Interpreting predictions of ML models provides valuable insights into why a model makes a specific predictions, helping stakeholders including end users and regulators understand and validate models' behavior. Apart from that, interpretability also facilitates the detection and mitigation of biases. Ultimately, the ability to interpret predictions enhances accountability and supports responsible deployment of machine learning in various applications. That's why in today's tutorial, I'm going to explain how to interpret predictions made by a text classifier. As you can see on my screen, I have a Jupyter Notebook open where I have kept the code for this tutorial. And at the beginning of the tutorial, I have included a sample image which shows how individual explanation or interpretation looks like. So as you can see at the beginning of the image, there are probabilities. So there are 5 different categories and the probabilities of each of them is present. So as you can see, the third category, sports hockey, has a highest probability of 69%. And that is the prediction of the model. After that, there is a bar chart which shows which words contributed to predicting this particular category named sport hockey. And as you can see, words like team, playoff, teams, win, buffalo, played, fans, cops. So these words contributed to predicting this particular target label sport hockey. And we can understand that these words are commonly used in hockey, and so we can come to conclusion that our model is using right words for the prediction. And then after that we have original text, and in that original text the words will be highlighted that were used to make this prediction, this particular target prediction sport hockey. So I will explain you how you can create this kind of interpretation using your machine learning model. So these are the table of contents of this tutorial. So I will first load data, and then we will encode the data. Then we'll train simple ML model, evaluate various ML metrics. And once we have trained ML model, we will interpret the prediction of that ML model using Python library named Lime. So you need to install it using pip install u and -u Lime. So this command will help you install it. And this library has implementation of a famous Lime algorithm which can be used to interpret prediction made by our model. So alright, so let's get started. First of all, I have over here loaded the dataset. So let me execute this line of code. And I have decided to use a famous 20 news groups dataset, which is available from Python library scikit-learn. And the dataset has nearly 20,000 text documents for 20 categories. So nearly there are 1,000 documents per category. But for this tutorial, I have decided to use only these 5 categories. As you can see, I have selected these 5 categories: atheism, computer graphics, sports hockey, science medical, and politics guns. So there are various categories in this dataset on religion, sports, computer graphics, politics, and so on. From that, I have selected 5 categories to keep this tutorial simple. Then I have loaded this dataset. So train and test splits are already present. And for categories, I have used selected categories, these 5 categories. And we can load this dataset using datasets.fetch underscore 20 newsgroups function, which is available from dataset. So let me show you one sample text. So this is how the sample text looks like. As you can see, this is the first example from our test dataset, and it's a second. So second is sport hockey, as you can see. The labels are from 0 to 4, 0, 1, 2, 3, and 4 because we have 5 categories. Alright, so let's move on. In this section, I have encoded our text data because all the machine learning models works on floats. So we need to convert our text data into list of floats. And for that purpose, I have used a count vectorizer, which is a kind of a vectorizer available from scikit-learn. And it's available from scikit-learn.featureextraction.text. And let me execute this line of code. So after creating a count vectorizer object, I have called fit transform on our xtrain dataset. So xtrain is list of text documents, and this will return the vectorized version of this text. So this will be list of floats. And then we have used this trained vectorizer to transform test dataset as well. And as you can see, the output is 2804 by this 44,444. So How this works is that it splits our text data into list of words, and it creates a dictionary of all the words, and all the words has unique index starting from 0 till the end 44,444. And for each example, whichever word is present in that example, the frequency of that word will be present at particular index. So over here, as you can see, I have included a sample image. In this, I have 3 examples. So this is a simple, only 3 text data set, only 3 text examples are present. And this is a dictionary which has words about, bird, heard, is, the, word, and you. And as you can see, for the first example, about is present 1 time, bird is present 5 times, heard is 0, the is present 2 times, and others are present 0 times. So as you can see, the words which are present in our example, the frequency of that word will be present at the index of that word. So about will be 0 index, bird will be first, and so on. And this will be present for all the words. So the dictionary will be consists of all the words in our total corpus. So this is how we can encode the dataset. So now this xtrain vect is a list of floats which we can give to our model for training purpose. Next, I have trained a simple classifier on our vectorized dataset. So from scikit-learn, I have imported random forest classifier over here. I have created an instance of random forest classifier, and then I have called a fit method on it, giving our vectorized dataset and the actual labels. So let me execute this line of code. So this line of code will train the random forest classifier on our dataset. So now that the training is complete, next what I will do is that I will make a prediction on test dataset, and then I will evaluate few metrics like classification report, confusion metrics, and accuracy. So in this cell, as you can see, first of all, I am using our trained classifier and calling predict method on it with our test dataset. So vectorized test dataset to make predictions. So y test spreads is a prediction on test dataset. Then I have called score method to calculate the accuracy. And next I have calculated confusion matrix and the classification report. So as you can see, the accuracy of our model is nearly 88% on trained data test dataset, which is kind of okay accuracy, but we will go ahead with that. And below that we have a confusion matrix for these categories, and below that I have a classification reports. So precision, recall, F1 scores for each categories are present over here, which you can look at. And now that we have trained our model and evaluated its performance, we can move on to the most important part of this tutorial, which is interpreting the prediction made by our model on individual example. In order to interpret predictions made by our model using Python library Lime, we first need to create an explainer object, which we will use to create an explanation. So from library Lime, I have imported a submodule named Lime text. So this is for interpreting text predictions. There are different modules for tabular data and image data as well. So first of all, I have created an instance of explainer, Lime text explainer, and the class name are given, which is the list of category, 5 categories. So next, after creating this explainer object, I have defined a simple function. So what this function does is it takes a list of text as input and it returns the probabilities for each example. So for each text example, what is the 5 probability for 5 classes? So to do that, I am vectorizing this text, and then I am calling a predict proba method of our classifier, which will return the list of probabilities for each example. So let me execute this line of code, and as you can see, for each example 5 probabilities are returned because we have 5 different categories. And this function we will use to create an explanation. So now in order to create an explanation object, we need to call explain instance method on explainer object which we created. And the first argument to this method is the text that we want to interpret. So as of now, I have selected the first example from our test dataset. Next is classifier function. So this classifier function argument expects a function that takes a list of text documents and returns the probabilities for each category. So that's what I have given predict function, which we defined in previous cell. And labels, list of labels for which we need explanations. So for this case, I have given y test of 0, which is the actual label, and we want to see that how our model is doing for this actual label. And so this will calling this method will return an explanation object. And in order to display that in Jupyter Notebook, I can call a method name show in notebook on that particular explanation object. So that's what I have executed over here. And as you can see, this is the first example from test dataset. And as you can see from this text, it seems to be from category sport hockey. You can see, and our model predicted sport hockey, as you can see, with the 81% probability. And here there are bar chart. So this bar chart shows which words were used to make this prediction. So words like team, playoff, teams played, Toronto, win. So these words are contributed to predicting this category sport hockey. And this seems to be right because these are the commonly used words in sports. And then in original text, which words contributed, that we can see highlighted over here. So it's that simple to create an explanation. As you can see, within 4-5 lines of code, we were able to create this particular explanation. And y test of 0, as you can see, actual label was 2, which was sport hockey. So now that I have created explanation, let me explain you few more useful argument of this function, explain instance. So over here, I have created one more explanation instance again on 0th test value or test example. And this time I have provided one more argument named num_futures to 25. So what this will do is that by default, if you look over here, by default num features is 10. So it shows me the top 10 features which contributed most to this prediction. But if I want to see more features, like I want to see 25 features, then I can provide num features argument. So that's what I have done over here. I have set it to 25. So 25 words it will show that contributed to prediction, as you can see. And as you can see, the words which like cup and fans, they are also contributing scoring to this prediction. So you can increase the number of features using this argument num_features if you want to see more features. If your dataset has like many features and you want to see like top 50 or so on, so you can do that using this particular argument. Next is again I have created explanation object, but this time I have not provided over here labels argument. As you can see, the labels argument I have not provided, but I have asked it to generate explanation for top 3 labels. So I want to see like what are the top 3 labels, top 3 probabilities. So let me execute this line of code. And as you can see, the top 3 probabilities are sport hockey, which is the first one, then science medical, you can see, and computer graphics. So in many cases, it happens that you have many different categories for your classifier, and you want to see for top 3 or top 5 labels, what are the words which are contributing. So you can make better decision and you can better understand your model that like which words are contributing to the prediction. So for that, you can use top labels. So it will show you that many top labels. And as you can see, for each one, we can see the words. So com and my and these words are contributed to this prediction being science medical, and then are some for computer graphics as well. Right, so that's it for today's tutorial. It's that simple to interpret prediction made by a text classifier using Python library Lime. If you have any questions or doubts, then please feel free to let me know in the comment section, and see you next time.